Hey everyone, welcome back to Pine Hollow, Auto Diagnostics. We're in northern Pennsylvania. It is beautiful country out here. Looking at a 2010 Mini Cooper. 100,000 miles, and guess what? The timing chain went. DIY, they tried to repair it. They forgot to put something on a sprocket, cranked it, bent all the valves, carnage. So then, another mechanic said, okay, I'll redo it. So they got it all together. It cranks, it starts, it runs, but only on 3 cylinders. So here it is. I figured if it was something simple, it wouldn't even be worth making a video, but it's not something simple. So, cylinder number 3 on the Misfire counters is dead in the water. And look at the plug on cylinder number 3. I didn't smell any gas on it. It looks perfectly clean. There's no combustion going on. This is its neighbor number 4. It's all black, so there's definitely, fuel being sprayed, and I did a cylinder drop test. 1, 2, and 4 are contributing, 3 dead in the water. But the spark is there. We swap plugs, we swap coils. It stays on number 3. You lift the coil up, it has a nice spark. So we're not missing spark in number 3. What are we missing? Compression or fuel? Compression sounds fine, so it has to be fuel. So next step here, this is where we're gonna, this is live here. I haven't done any testing yet. These are the 2 wires going to the fuel injector. So this is a regular, port injected engine, thank goodness. No turbo. So we should be able to get a good capture of, is the computer turning that injector on and off? If it is, and we were getting no fuel, well then it's a stuck fuel injector. And we can compare it to a known, good working one with the scope and just see what these injectors are doing. So I think it's lack of fuel in cylinder number 3. So number 3 plug, someone already messed up the threads. It wasn't going in very nice. So we're just running it, chasing the threads down. There we go. M12 by 1.25. You want to blow that out with some compressed air?
Yep. I'm going to put some if you want.
Okay, so let's run this thing. So I moved plug and coil number 3 to number 4, number 4 to number 3. And I assume we're still going to have a Misfire number 3. Let's look at the scan data. I love the key. It's like a round thingy. Alright, Misfire detection. Okay. Graph it. There it is. Number 3 is counting up. It's dead in the water. Now let's check that fuel injector. So let's go low tech first, just a test light to battery ground. Injector number 1, there's an orange and a white. They all have an orange and a white, so I don't know which one's power, which one's control, but if the test light's bright, constant bright, that has to be the power feed. The other one, see it's pulsing and it actually causes the engine to run poorly. That's energizing the injector. Right there. Very neat. So what if we shut it off and turn the key back on? Okay, key's back on. Are we going to get a power feed to the injector? Yes, we have a power feed, and if we touch this to ground, it should click the injector. Let's listen for it. Yep. So it clicked once. That's for number 1. Let's do the same experiment on number 3. Alright, so we're on injector number 3 now. Key's still on, so we have a good power feed. And if we touch this wire and the test light lights up, dimly, the current should be passing right through the injector. And it is. Now let's run the car and see if that wire is being pulsed. There you go. You heard that change? So that's bright, that's dim, but it's not pulsing. Interesting. Okay, so we have good power feed. Let's see if it clicks. No clicky. So in this case, I think we're going to have to put a scope on this one and number one to see what's going on. Now, keep in mind, if the car detects a misfire, it could shut off the injector driver. So we definitely need a scope on startup to see if all the injectors are being pulsed, and perhaps the computer strategy is to turn it off. But the fact I'm not hearing a click at all, that's a little concerning. Alright, so 2 channels. Injector number 1 control, injector number 3 control, PicoScope. We just need 1 capture to kind of the fork in the road. So ignition on, we should see 12 volts. Yes, we do. And let's fire it up. So we see activity on both signals. That's good. Let's pause that and zoom in. Alright, so we have injector pulses on both injector 1 and number 3. That's good. That means the computer is trying to turn the injector on. There's nothing wrong with the computer driver or the wiring. So that just ruled out most of the problems. Now, you know, the injector pulses themselves look identical, right? So raise the RPMs, they get closer together, you get bigger pulse width. Right here, we're just at idle. Look pretty close. However, if we keep zooming in, what do you see right there? This is called a pintle hump. That's when the pintle is dropping back and closing the injector. Check out the red trace, no pintle hump. Isn't that beautiful? So if you're too zoomed out, you won't see it. You need to zoom in on this falling edge after this inductive spike to see if the pintle actually mechanically moved. Yes, it did on number 1. Number 3, the injector is just mechanically stuck. Electrically, it's perfect. That's why I wasn't clicking when we tried it with the test light. So that's it. We're done. We have a stuck injector number 3 on this Mini Cooper. Without the scope, you could not definitively say 100%. But here, a couple minutes, hook up a couple leads, get 1 capture, and we're done. That's how you guarantee your diagnosis. So once they get the injector in, we'll make sure it runs, and we'll do a follow-up. But thanks a lot for watching. We'll see you in the next one. Bye-bye. Hey everyone, welcome back to Pine Hollow out of Diagnostics. We're at the border, Waverly, New York. Another Chevy Silverado 1500. This is a 2017 model. Customer complaint is check engine light keeps coming on. He said it's been on for about a week. And Bill scanned it for codes, something to do with the fuel pump performance. Okay, so the code that we're dealing with is this P2635 fuel pump flow performance. Now, I did a little bit of research on this code. This truck is direct injected, so it has the low pressure pump in the tank and then a high pressure pump on the engine. This code has to do with the low pressure pump system. There's a sensor that monitors the pressure on the low side, and if the desired and the actual don't agree by more than 5 psi, it throws this code. So first thing I want to do before going to all data is just look at some live data on the scanner, see what the desired pressure is, what the pump command is, what the sensor is reading, and just gather some data before we jump into this thing. Alright, so in the ECM, we'll read data stream. And we want to go to fuel system data. And there's two lists, so we'll just try list one. So there's desired fuel pressure, desired fuel rail pressure. So this is low side, high side. Okay, and then we have a whole bunch of stuff. Fuel pressure sensor, fuel pump command, fuel rail pressure sensor 1 and 2, fuel pump enable command. Look at that. We'll just look at as many data PIDs as we think are relevant. Fuel tank pressure sensor just for kicks. There's fuel rail temperature sensors. Don't care about that. Well, let's just pick those 11 data PIDs. Let's graph them. Okay, so desired fuel pressure right now is 61 psi, and we're at 0. 0.7 volts. Fuel pump command is 0%. Fuel pump enable command is off. In the fuel rail, we're at 348. Okay, so let's start it up. Okay, look at that. Fuel pump command 100%. We're only at 25 psi. It wants almost 60. That's a problem. Let's rev it up. Settles back down. About 22, 20, 26. It's a little shaky. But on the fuel rail, 580 desired, 580 actual. So the high pressure pump is fine. It's still being fed, but it does not like this discrepancy. 45 desired, 25 actual. If we shut the truck off, I'm wondering why it drops to 0 instantly. Shouldn't it hold pressure in the low side? You would think it would. Drops off instantly. Okay. Screenshot of that. So we're dealing with a low pressure, fuel pressure situation. Now what are the variables? Variable 1. Can we trust the fuel pressure sensor? That's a question. This fuel pump is controlled by a fuel pump driver module that lives above the spare tire. Again, salt belt truck, it's 7 years old, so that could be another variable. What's the quickest and easiest test we can do to say, is the fuel pump good? What's the maximum pressure that the fuel pump can put out? My idea is, let's eliminate this fuel pump driver module altogether and just send full power to the pump, look at the pressure on the scanner. If it goes to whatever, 80 psi, we know the pump is okay. It can, deliver that pressure, and we'll go from there. If it stays at 26, we can do, current ramp. We want to make sure powers and grounds are good. So let's do some basic checks at this fuel pump driver module. Okay, so fuel pump driver module. This is the OE diagram. There is our fuel pump. Let's look at it this way. And the module itself, the main high current feed battery positive is on pin 1, and the main ground is on pin 9. So 1 and 9 are power and ground, and then 8 and 16 is the feed and the return from the fuel pump. Okay, great. So the connector on this fuel pump control module, it's 16 pins, and the side pins 1, 8, 9, and 16 are those high current pins. So let's unplug it, check for good power and ground on pins 1 and 9 respectively, and then what we can do very easily is just jump 1 to 8 and 9 to 16. So 1 to 8 will be basically powering up the fuel pump, and then 16 to 9 will ground the fuel pump. and see what the fuel pressure is when the pump is on, 100% duty cycle. So the command right now, it's saying that the engine control module is requesting 100% duty cycle, but it's only putting out 25 psi, which is not nearly enough. Alright, so here's our fuel pump driver module. Let's do a quick visual inspection. See any green crusties anywhere? Not yet. Let me try to... I think there's a lock on top of this thing. Let me try to disconnect it, and we'll get to that connector. Alright, got the module off. It's all dusty and dirty, obviously, but not seeing any corrosion or anything like that. So there's the part number. Connector looks okay. So here we have our red and black, and then the gray and black and light green. So all we have to do is jump this to this and that to that to energize this fuel pump right now with the truck off. Let's put a test light on here, 5 amp test light between power and ground, make sure that lights up brightly. Okay, so we got our AES wave adapters, 5 amps, power to ground, nice and bright test lights, no power or ground problems at this connector. Okay, so now it's either module or fuel pump. So now let's jump from here to here and run this fuel pump, and then look at scan data, see what the pressure reads. Okay, so got my adapters rigged up. So once we connect this to this, the pump should run full speed. And what I want to measure is the current on the fuel pump right here on the meter, and also monitor scan data right here on the scanner. So Bluetooth scanners are obviously amazing. So let's try it. So I'm going to connect it right now. About 8 amps, 20 psi. Do you guys hear that sound? It's almost like something squirting inside the tank. So I expect the pump to kind of load up and go and achieve maximum pressure. That's not happening. It's only achieving 20 psi. The pump is spinning just fine, drawing great amperage, but I think there's an internal fuel leak inside the tank. So either there's a pressure hose coming from the pump to the outlet that's has a hole in it. So basically Bill wants me to tell him, does he need to drop the tank? So yes, the tank needs to be dropped, but I don't think you'll need a whole new pump unless it's part of the whole assembly and you can't service it. Hopefully there'll be no parts required repair, maybe a little clamp or something. We'll do follow-up once Bill gets this truck fixed.